Okay, an interesting question. So many of you guys would not be familiar with such topics as of now, but I'm just assuming that you guys know the idea of an arithmetic mean. Now I'm just going to give you an idea about the arithmetic mean. So if there is a string of numbers, okay, and I'm just using a visual representation. If there is a string of numbers which are in arithmetic progression, so if you know how many terms are there, so the number of terms, you can predict the arithmetic mean is going to be somewhere in the middle. Okay, so we are going to use that concept, and also we know one more thing, that arithmetic mean is equal to the average or the simple average of a system of number that is given by this expression. Am is equal to the summation of all those numbers. I'm just using notations, nothing usual about this, by the total number of terms. So if I multiply the arithmetic mean into the total number of terms, I can get the total. Okay, I can get the total or the sum total. Okay, so let me use that idea to see how we can solve this question. Now the situation that is given in front of me is that there are numbers a1, a2, a3 all the way till a50. So the total number of terms, I think you can see pretty clearly in front of you, that is 50. And because it is said, given rather, common difference of 1, so the common difference is given as 1. Now what I can make inference out of it is that I can take variable like x, the next term will be x plus 1, and so on till x plus 49. Okay, now the value of a2 plus a4, a6 all the way till a50. Now the first inference that you have to make is that how many terms are going to be in that expression. Now obviously if you pay attention, this is a2, a4, a6. Okay, so every alternate term is there. So because every alternate term is there, and in the parent sequence a total of 50 terms were there, and half of the terms I can precisely say, or every alternate term is there, so every alternate term is not there. So effectively the inference that I can make is that the number of terms in the sequence 2 is going to be 25. Now this much I know. I have to also know the first term. Now that I only will be able to calculate once I plug in the next bit information, which is given to me as a1, a2 and all that. So if you look into this carefully, you will see there will be 50 x's available in this. So I will try to write that 50x over there, and then there will be 1 plus 2 and the usual thing till 49. This will be equal to 75. Now of course you have to solve this equation or expression, whatever you want to call it. So this is the sum of first n natural numbers. This is going to be 49 into 50 by 2 into 50 by 2. Okay, sorry, that is added to 50x, that is equal to 75. The first thing that goes into my mind, 75 is much lesser than this 49 into 50 by 2. So obviously the value of the first term x will come out to be negative. If you do your mathematics, you will find that, okay, let's do that. This is 25, multiply this by 4, divide that by, so this is 4900 by 4. 4900 by 4 can be written as 4 1s are 4, 4 2s are 8, 1 0, 2s are 8, 0. So 1225. 1225 when subtracted from 75 will give me 25 goes 1200, 50 goes 1150. So this effectively gives me x is equal to minus 1150 by 50. 5 2s are 10, 3s are 15. So x is equal to minus 23. This is very important. This is the first term of the expression. Now in the sequence, the summation of which is asked, I am asked the second term onward. So the second term is just an addition of 1 into this, that will give 1 into it, not multiplying, I'm just saying. So the a2 can be written as minus 22. Now it will be helpful for you if you can just quickly tell me what is the last term of the sequence. The last term of the sequence can be found out very easily. That is going to be, but do I even need the last term? I'm just thinking. I don't think I need the last term, but even if you do, Okay, just let's just calculate it anyways. Okay, so what's the big deal? So A50, because this is important when we will be able to, when we will calculate for the second sequence. So A50 will be given as minus 22 plus n minus 1d, that is the formula. So n minus 1 is 49 and d is 1, so straight away subtracting 22 from 49, that will give me 26. Okay, so this is pretty straightforward. I don't think it was very difficult. Now the first term is there. I'm talking about the next sequence. Now see how the juggling happens in my brain. The first sequence, the second sequence. For the second sequence, this is my first term, this is going to be my last term, and there are total n terms, 25 terms. Now if you're a bit careful, if there is a string of 25 numbers, I hope you can appreciate the fact that the 13th term is going to be the arithmetic mean, and I just discussed that how we will find out the sum total of the second sequence, that is through that formula, arithmetic mean into total number of terms. I already know the total number of terms, that is 25. I just need to calculate the arithmetic mean of the sequence, which is going to be not very difficult. It's actually very easy. So arithmetic mean, or rather the 13th term, not the arithmetic mean, I'm talking about the 13th term, that is the arithmetic mean, right? So the 13th term will be a plus 12d. This is how we have been studying, in our classes. So a is given to as minus 22. Please pay careful attention to the sign of the terms. Plus 12 into, is it going to be 1 or 2? It is going to be 2, because we're talking about the second sequence. 24 minus 22 gives me 2. Now this gives me my answer as 50, because just now I said arithmetic mean into the number of terms. Arithmetic mean we just calculated as 2. Number of terms I have told you that is going to be 25, and that is equal to the sum of the sequence. Okay, so possibly a summation of I2. A good one, an interesting question. Thank you.